makers! Today I decided to learn the piano, but instead of settling for the ordinary, I chose to create my own masterpiece using the MakePython ESP32 Dev Board, this Elektor guide, and the magic of MicroPython. So get ready to witness a symphony of innovation. Today's project is inspired from the MakePython ESP32 Dev Kit, which is available on the Elektor store. It includes a quick guide to mastering the ESP32 microcontroller. The aim of this project is to show how various tones can be generated to create a simple melody. All you need is a simple breadboard, the MakePython ESP32, a buzzer, and few jumper wires that are all included in the Makerfabs Dev Kit. The circuit is very simple. The input of the buzzer is connected to port pin IO22 of the dev board. Now let's move to the code. The program is written by Dr. Dogan Ibrahim, the author of this quick guide. When playing a melody, each note is played for a certain duration and with a certain frequency. And we need a certain gap between every two successive notes. The harmonic of a note is obtained by doubling the frequency. The next thing we want is to know how to generate the sound with the required frequency and duration. In this project, we'll be generating the classic Happy Birthday melody, and thus we need to know the notes and their durations. The durations are in units of 300 milliseconds. And that's why in the program the values are multiplied by 300. The frequencies and durations of the melody are stored into arrays called frequency and duration. Inside the program loop, the melody frequencies are generated with the required duration. The tone output is stopped by setting the duty cycle to 1023 because the buzzer is triggered on low voltage. And a small delay of 100 milliseconds is introduced between each note. After 3 seconds of delay, the melody is repeated. Of course, you can try higher harmonics of the notes for clearer sound by multiplying the frequency with an integer number. The sound quality of a buzzer is not that good, so you can use a loudspeaker with an audio amplifier for much better and clearer sound quality. After running the code, here is the result. And that wraps up my own piano making journey. But fear not, this is just the beginning. I'll continue tinkering, and who knows, maybe next time you'll witness an even more remarkable version of my DIY piano. Until then, stay tuned for future upgrades, and don't forget to subscribe to Elektor TV and to like this video.